Every single day of our lives, we deal with heat and mass transfer. From heating up leftovers, cooking food, to trying to warm up in the winter or staying cool in the summer, heat transfer is inevitable. But what really is heat and mass transfer? Hi, I'm Eliza, and together, let's break it down one by one. Heat transfer is the thermal energy exchange between two objects due to some spatial difference. This can occur through conduction, convection, or radiation. Mass transfer, on the other hand, is the transport of a substance from one place to another. This can happen through diffusion, convection, and other mechanisms. For further understanding of the forms of heat transfer, let's boil some water. So we have an induction cooker and a pot we place on top of it, and once we turn it on, heat is generated and dissipated by the cooker. And since the bottom of the pot is in contact with the cooker, heat is transferred from the cooker to the pot. And now that's conduction. Inside the pot where the water is, the bottom part becomes warmer slowly, and it rises as it is heated and falls as it is cooled. This cycle of heat transfer between fluids is called convection. Lastly, when we lift up the pot from the cooker, heat is still moving from a distance, right? And now this is called radiation. Simple, right? We've all been familiar with these forms of heat and mass transfer. But for today, we will be only focusing on one, and that is radiation. Radiation is the energy emitted by matter in the form of electromagnetic waves or photons as a result of the changes in the electromagnetic configurations of the atoms or molecules. According to the Safon-Boltzmann law, the amount of radiation emitted per unit time from an area A of a block body at absolute temperature T is directly proportional to the fourth power of the temperature. Well, simply put, radiation is a transfer of heat through electromagnetic waves, such as the heat you feel from the sun. We've all known and heard that too much radiation exposure is bad for our bodies, our health, our environment, and well, that is true for some cases. There are many kinds of radiation, and that includes radio waves, microwaves, infrared, X-rays, and many more. Some are beneficial and some are really harmful in large doses. But for now, let's focus on the effect of radiation heat transfer on aerospace systems, as they are particularly important in that field. And because, well, I am an aerospace engineer. Ring student. But wait, what are aerospace systems? Well, aerospace systems are the various systems and components that are used in the design, construction, and operation of aircraft, spacecraft, and other related vehicles. Well, yeah, basically, aerospace systems are the parts and components used in flying objects such as airplanes, spacecraft, rockets, satellites, and many more. And in these systems, heat and mass transfer plays a very critical role in their performance and safety of these systems. So how does radiation affect aerospace systems? Let's look at this example. We have the supersonic aircraft called the Lockheed SR-71 Blackbird, known to be the fastest air-breathing manned aircraft in the world. This was used by the US Army as a spy plane, and its top speed was at Mach 3.2 or 3 times faster than the speed of sound, or around 3,500 kilometers per hour. That's fast, right? And of course, traveling around at high speed means that you have to experience high temperatures as well. The wings and fuselage of the aircraft were between 600 to 900 degrees Fahrenheit during normal operation at Mach 3.2. This heat is created from two main sources: the aerodynamic heating of the nose and wings, and heat due to the jet's exhaust. Extremely hot, right? Well, imagine putting yourself in that situation, traveling at that speed, fully uncovered. Well, you'd probably be burning by now. So how was this resolved? Well, the SR-71 has been designed and engineered tremendously and meticulously to withstand these temperatures for its lifetime. The material selection was important to know which were best suited for this use. The aircraft skin was made of titanium alloys, which they bought secretly in Russia because they lack of it, and Russia has a lot of it. And these titanium alloys have high thermal conductivity and high strength to weight ratio. This means that the skin can quickly transfer from the hot air outside the aircraft to the cooler air inside the aircraft. Special coatings on the skin was also applied to the SR-71, which helped reduce absorption of radiation heat and prevent the skin from overheating. Aside from the heat, a unique fuel called the JP7 was also used for the SR-71. It has a high flash point that can withstand high temperatures. This fuel is essential to the operation of the aircraft as it helps dissipate the heat generated by the engines. Overall, radiation heat transfer is a critical form of heat transfer in the operation of the SR-71 Blackbird. The aircraft's unique skin and fuel system help to manage and ensure that the radiation heat that is dissipated in the aircraft is being properly addressed, and that ensures the safety and success of the operation. Whew, that was a lot. But today I shared to you what heat and mass transfer is, its forms, its applications, how it affects aerospace systems, and how it is addressed, specifically on the majestic SR-71 Blackbird. So I hope you learned something today. Thank you so much for watching. Bye!
Grabe, hantud am guhit and mas gihapon.